Okay, so we have several types of standard forms of arguments, some valid and then some invalid. First, we're going to use the valid arguments and go through each one of those and give you an example of those, and then we'll go through the invalid arguments a little bit later. So the first standard form of an argument is called direct reasoning. If P then Q, that would be my premise 1. We also have P, that's my premise 2, and then the line is breaking up the premises and the conclusion, and then you have therefore the conclusion. Okay, so that's how you would write it in symbolic notation. So if P then Q, well, P is true because the premises we assume to be true. Therefore, we can say that the consequent is true. And this is a valid argument. So here's an example. If I eat, then I have a mouth. I eat, so therefore you can say you have a mouth. Okay. The contrapositive reasoning, again, we have premise 1 and premise 2 implies the conclusion. So my premise 1 is if P then Q. My premise 2 is not Q. So we can assume that those two are true. My premises are true. Do those two true premises imply that we have a not P? So here's an example of that. If I eat, then I have a mouth. That's my if P then Q. Well, if you can say I do not have a mouth, well, then therefore you can say you do not eat, which is contrapositive. It's contrapositive because we're saying if not Q, then does that truly imply not P? And the answer is yes, because the direct reasoning, which is the conditional, and the contrapositive, those two are both equivalent statements, so they're both valid. Okay. Another type of valid argument is called disjunctive reasoning. So we're talking about P or Q. So we have P or Q. If we have not P, therefore Q. So if we know that the two premises are true, we can imply that Q. Because in order for P or Q to be true, well, one of them has to be true. If we know from premise 2 that P is not true, we know that because premise 2 we're assuming to be true, then we must have Q being true. So this is a disjunctive reasoning, and it is true. It goes for not P or not Q. It works the same. So an example is I eat or I drink. So if you do not eat, therefore you must drink. And that is a valid reasoning. Our last type of valid reasoning is if P then Q, if Q then R. Therefore we can say if P then R. So this is a transitive reasoning. If P then Q, my antecedent and my consequent, well, in this next premise, my consequent of the first statement becomes my antecedent, so that also implies R, so therefore P implies R. The contrapositive of that would be if not R, then not P, and both of those statements would be true, and that's called transitive. So if I eat, then I have energy. If I have energy, then I can run. If those two statements are assumed to be true, then if I say, if I eat, then I can run, would be a valid conclusion. The other valid conclusion there would be, therefore I cannot run, then I did not eat. And that would be the transitive reasoning. All of these are valid, standard types of reasoning that you can use. Now, we're going to go ahead and give you an example and see if we can't prove one of those to be true. So we have premise 1. If Cole plays in the game, then the Astros win the game. Premise 2. The Astros did not win, so we conclude that Cole did not play in the game. So our P would be Cole plays in the game. The Q would be the Astros win. So my premise 1 would be if P, then Q. Premise 2, the Astros did not win. So we're going to assume not Q is true. We're going to assume that whatever the premise is that the argument gives me, that they're true. So can I say that the conclusion is also true? making this a valid argument. The conclusion says Cole did not play in the game, so that would be not P. Okay, so we're going to actually test this to see if it is true, and then if it implies a true statement, then we can say that the whole argument is true. So our first one is premise 1, if P then Q. Implies is only false if the antecedent is true and the consequent is false. So if true then true, that's okay. If true then false, nope, that's the one bad case. If false then true, that's true. If false then false, that's true. Next, we're going to do premise 2, which is not Q. So I just go to the Q column and negate every single one of those truth values. Now I'm going to do premise 1 and premise 2. So and is a conjunction which says is only true when both are true. So true and false, that's false. False and true, that's also false. False and true, that's false. True and true, that's the only one that's going to be true. Next we have not P. Okay, so I have the first column, which is P, and I want to do not P, which in this case is our conclusion. Each one of these columns are done on purpose so that we're proving our argument. So not P is going to be false, false, true, true. And then our last one, which we're going to call our argument, says if we have our premises, does that imply our conclusion? So we're talking about the premise column and then the conclusion column. So if, and we're going to go this direction, if false, then false. Well, that's true. If false, then false. That's true. If false, then true. That's still true. If our antecedent is false, which is our premises this time, then we can say that the whole conditional statement is true. And the last one, if true, then true, that's also true. What do you notice about the entire last column here? Every single one of our arguments is true. If we assume that our premises are true, that truly does imply that our consequent is also true. Therefore, we can say that this argument is valid. Now, if you would have looked up at the top, you would have noticed that this is an example of the contrapositive reasoning. Now, if you could identify that this was an established standard form of argument, then you actually don't need to do all of these truth tables to identify validity, which is really cool. So I'm going to scroll up here. If you would have looked at this right here and noticed that if P then Q, if not Q, that implies not P is the same as this contrapositive reasoning, you could have just stopped right in the beginning and said, this already is a valid statement because of the contrapositive reasoning, and it would have avoided the whole situation where you had to do the truth tables to prove that it is valid. So that's one really cool thing, that if you can learn what are the valid arguments and apply that, you don't have to do all of the truth table work.